Hello everyone, Namaskar. So let's solve one more question from Fourier series. So this is find the half range Fourier sine series. It should be Fourier sine series for the following: fx equals to x sine x for x between 0 to pi. So we know that the Fourier half range sine series is given by fx equals to summation n equals to 1 to infinity bn sine. In angle we have n pi x by, here you can see it is going from 0 to pi, so we'll write pi. So your fx will be summation n equals to 1 to infinity bn sine nx. Okay, so we need to find bn in this case, which is 2 by pi integral 0 to pi. What is bn? Fx sine nx. So fx is x sine x and with that you have sine nx. Now here it is the product of three functions. So first of all we'll convert this to the product of two functions by using some formulas. So we know that cos of a plus b is cos a cos b minus sin a sin b. And cos of a minus b is cos a cos b plus sin a sin b. So because we want to keep sine term alive, so subtract this. So we will get cos of a plus b minus of cos a minus b equals to minus 2 sin a sin b. Or sin a cos of a plus b minus cos a minus b. Sorry, it will be negative, so it will flip. Cos of a minus b minus cos of a plus b divided by 2. Okay, cos of a minus b minus cos a plus b divided by 2. So bn x. This will be sine x minus nx. So sine x minus nx. So 1 minus n into x minus, sorry, it will be in cos. So and it will be minus cos x plus nx. And this whole divided by 2 also. So in next step I am doing some changes. 2 comes out, so 2 and 2 gets cancelled, so bn is 1 by pi. Also I can separate these two terms, so 1 by pi is 0 to pi. Cos 1 minus n is same as cos n minus 1, because cos minus theta is cos theta only. So x cos n minus 1. Okay, minus 1 by pi 0 to pi x let's solve this one by one. So in this, the first function is this, second function is this, first function is this, second function is this. So bn will be 1 by pi, first function as it is, integration of second function, so it will be sine n minus 1x divided by n minus 1 minus integration of derivative of x is 1, integration of cos is again sine n minus 1x divided by n minus 1 dx goes from 0 to pi minus 1 by pi, again first function as it is, integration of cos is sine minus integral of derivative of x is 1, integration of cos is again sine and it goes all the way from 0 to 1. Fine. Now bn will be 1 by pi x sine n minus 1x divided by n minus 1. Integration of sine is minus cos, so minus minus plus cos n minus 1x divided by n minus 1 whole square minus 1 by pi x sine 1 plus n x divided by 1 plus x. Again integration of sine is minus cos, so it will be plus cos 1 plus n x divided by 1 plus goes from 0 to pi. Now we'll start putting the values. So bn will be equal to 1 by pi when you put pi, so sine n minus 1 pi, that will become 0. Okay, then cos n minus 1 pi will be minus 1 power n minus 1 divided by n minus 1 whole square. So minus 1 power n minus 1. This was about upper limit. Coming to lower limit, so when you put 0 in lower limit, first term is going to become 0. Second term is cos 0 is 1 divided by n minus 1 whole square. So then we have minus 1 by pi. Here if you put pi, then sine n plus 1 pi is going to become 0. Cos n plus 1 pi is again minus 1 power n plus 1 divided by n plus 1 is already there. One mistake I did. Integration of sine is cos, and again 1 plus n, one more will come, so this will become 1 plus n whole square, so it will be n plus 1 whole square. Okay, then coming to the lower limit, when you put 0, it will be 0. When you put 0 in this cos term, then it will become 1 upon n plus 1 whole square. Lower limit, so negative. Okay, now let's simplify this. So because n plus 1 n minus 1 is coming, so we can do one assumption that when n is even, so we know that when n is even, n plus 1 will be odd, because next term, if any term is even, next term will be odd, and a term before will also be odd, so n minus 1 will also be odd. Okay, now let's simplify bn now. So bn will be 1 by pi minus 1 power n minus 1, and because n minus 1 is odd, so this will be minus 1 divided by n minus 1 whole square minus 1 divided by n minus 1 whole square minus 1 by pi. Again here, because n plus 1 is also odd, so this will be minus 1 power odd is minus 1, n plus 1 square minus 1 upon n plus 1 square. So bn is 1 by pi this is minus 2 by 1 by pi if I take common. So minus 2 by n minus 1 whole square minus 2 here also, but this becomes plus, so 2 by I can further take 2 common, so bn becomes minus 1 by n minus 1 whole square plus 1 by n plus 1. Now let's simplify this. N plus 1 whole square plus n minus 1 whole square. N plus 1, n minus 1 is n square minus 1. So Bn will be 2 by pi n square plus 2n plus 1 plus n square plus minus 2n plus 1 . So 2n gets cancelled. Fine. And here you see n plus 1 whole square and 1 minus sign was also there. So this will be minus of this. So again some changes. First of all, this will be minus. So this term will become negative. Then this term will become negative and the next term will also become negative. So I will get minus 2n minus 1. Now if you see n square terms cancels, this cancels. So Bn will be minus 4n divided by pi n square minus 1. And obviously this is not defined for denominator when becomes 0. So n square minus 1 whole square will be 0 at n square minus 1 equals to 0, n square equals to 1, n equals to plus minus 1. Obviously we are not taking care of minus 1 because our interval is from 0 to infinity. So n equals to 1 we will not take. So this is not defined for n equals to 1. So we'll have to find Bn separately for n equals to 1. That is, we have to find B1 separately. Okay. So first of all, the second case when n is odd. Okay. So when n is odd, n plus 1 will be even. N minus 1 will be also even. Now in this case you see carefully what will happen. That n minus 1, n plus 1 both will be even if n is odd. So minus 1 power even will be 1 only, and 1 minus 1 will be 0. This one and minus this one, because denominator is same. So 1 minus 1 0. Same here, because n is odd, so n plus 1 will be even. So minus 1 power even will again give you 1, minus 1 because denominator is same, again give you 0. So this term will be 0 in that case, because 0 minus 0, that will give you 0. Okay, so Bn in that case is obviously becoming 0. So we don't need to think much in that case. So Bn is only existing when your n is even, and except for the case when n is Now why we are taking n equals to 1 here also? Because we defined this case for n equals to even, so we should not take n equals to 1 anyway in this particular case. Okay, let's check what happens for b1 separately. So when it comes to b1, so that will be 2 by pi, 0 to pi, when you take n as 1, so 1 minus 1 0, cos 0 is 1, so from here you are getting 1, and 1 minus cos 2x by 2 is what you are getting with x. One minus cos 2x by 2. 1 minus cos 2x is 2 sine square x, and divided by 2, so that becomes sine square x. So this is a better format to integrate. So 2 by pi, if I take 2 out, so 2 and 2 gets cancelled, so I get 1 by pi integral 0 to pi x 1 minus cos 2x. So b1 will be 1 by pi first function, second function. First function as it is, integration of let's break this for our smooth calculation. So if you break this, so b1 will be 1 by pi 0 to pi x dx minus 1 by pi 0 to pi x cos 2x dx. So b1 will be 1 by pi, this will be x square by 2 from 0 to pi, and in this take this as the first function, this as the second function, this we didn't take, so minus 1 by pi first function as it is. Okay, integration of cos is sine 2x divided by 2 minus integration of derivative of x is 1, integration of cos is again sine 2x by 2. So b1 is 1 by pi x square from 0 to pi, so pi square by 2 minus 0, and now minus 1 by pi x cos 2x, sorry, x sine 2x by 2, Integration of sine is minus cos, so it will be plus cos 2x by 4. So b1 is 1 by pi into pi square by 2. So this becomes pi by 2. And this becomes, when you put x as pi, so sine 2 pi is 0, x as pi. So cos 2 pi is cos 360 degree. That is same as cos 0, which is 1, so 1 by 4. Minus lower limit, again this becomes 0, again cos 0 is 1, so 1 by 4. So this becomes anyway 0, so b1 you are getting as pi by 2. Okay. Fine. So here you have to think one thing, when you are taking n as odd. Okay. So first of all you have to see that this expression of bn is not defined when n equals to 1 or n equals to minus 1. Okay. So we will have to find b1 separately in both the cases. Okay. So b1 will find separately, then we'll use these two cases. This is the case 1 when n is even, and this one was the case 2 when n was odd, except for n equals to 1. Okay. N was odd except for n equals to 1, because at n equals to 1 denominator was anyway becoming 0, so it was going not defined. So we find that case separately. Now we can find final expression, which is fx equals to summation n equals to 1 to infinity bn sin nx was there, but at n equals to 1 we also have a different thing, which is pi by 2. So at n equals to 1 multiply pi by 2 with sin nx taking n equals to 1. So sin nx, put n equals to 1, so that will be sin x plus summation, again summation n equals to 1 to infinity. 1 we have already taken, and also we have a condition that when n is even, then only it is giving some value. So when n is even, then it is given as minus 4n by pi n square minus 1 square. Okay. So this condition was not needed here, because we took n. This was condition we need to clarify before coming to the cases. So we already took this condition. So minus 4n divided by pi n square minus 1. When n is even. So start putting even. So this is minus 4, even value will be minus 8 when you put n equals to 2, n equals to 0, it is anyway going to cancel. So n equals to 2, so minus 8 by pi, and it will going to give you 4 minus 1, 3 square. Okay, next term it is going to give you at n equals to 4, so minus 16 by pi, 16 minus 1, that is 15 square. Plus dot 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 dot. Okay. So fx is pi by 2 sin x okay, and minus 8 by pi I can take common. Also I missed one thing. With this I had sin and x also. So let's multiply. No, we can't multiply individually. We have to put the values. So for n equals to 2, it will be sin 2x minus 16 by pi 15 square, and it will be sin 4x plus dot 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 dot. Okay, so minus 8 by pi I took common. So first one will be sin 2x by 3 square minus 2 by 15 square minus I took common, so this will be plus. So this is the final expression, fx equals to pi by 2 sin x, because the overall expression was not defined for n equals to 1, so we find b1 separately, which came out to be pi by 2. You have to multiply that by sin nx. For n equals to 1, sin nx is sin x only, and these are the remaining terms, minus 8 by pi sin 2x by 3 square plus 2 by 15 sin 4x, 2 by 15 square sin 4x, and so on. So that's it from my side. It was quite a lengthy question. I hope you enjoyed it. Thanks and have a nice day.